Good afternoon, everyone. Welcome back. Trust you had a good lunch. Welcome back to Engineering the Inka Empire, a symposium on sustainability and ancient technologies. We had a wonderful morning, some very detailed work that was reported on, excellent research being done on the Inca Road, Inca construction, and in particular, of course, the engineering, in support of an exhibition that should open here in 2015 on the Hapanyang, the Great Inca Road, that will incorporate a lot of this research. Good afternoon program as well. This afternoon, we are fortunate to hear from John Ochsendorf on the topic of engineering in the Andes, the Indigenous Suspension Bridge Technology. John Ochsendorf has been on the faculty of the Massachusetts Institute of Technology since 2002 and is the class of 1942 Professor of Architecture and Civil and Environmental Engineering. He earned his Bachelor of Science in Structural Engineering and Archaeology from Cornell University, where he has informed me that he was in one of my classes back then. So if I can take a little credit for his vast knowledge, the teacher certainly, or the student certainly has surpassed the teacher in this one. He earned his Bachelor of Science again in Cornell University, where his undergraduate thesis carried out the first of, it's hard to find the light back in here, technical study of Andean suspension bridges. Ochsendorf earned a Master's of Science in Civil and Environmental Engineering from Princeton University and a PhD in Structural Engineering from the University of Cambridge. He is a founding partner of Ochsendorf, de Jong and Block LLC, a consulting firm specializing in historical structures. He has won numerous awards for research in structure engineering and architecture, including a graduate research fellowship from the National Science Foundation, a Fulbright predoctoral scholarship from the J. William Fulbright Foundation, a Rome Prize from the American Academy in Rome, and, not the least, a MacArthur Fellowship from the John D. and Catherine T. MacArthur Foundation. Welcome, John Ochsendorf.
Thank you very much, Jose. It's absolutely an honor for me to be here, and I'm excited to share my work and some open questions on suspension bridges in the Andes Mountains. I would like to start with a slightly personal note that I grew up a few hours west of here in the mountains in West Virginia, and when I was a child and got to come to the Smithsonian, it really kind of lit a fire in me and a thirst for knowledge. So it's a tremendous privilege to be here. And at that time, I was fascinated with indigenous cultures. So it's a particular pleasure for me to be here at the National Museum of the American Indian. And I was lucky enough at 10 years old to have a really exceptional teacher turn to me and say, "I'd like you to write an extended research paper, and I've chosen the topic for you." I said, okay. And she said, the topic is the Inca Empire. And it wasn't until years later that I found that, and that I'd written a couple of paragraphs about the Inca road system and even mentioned the bridges at 10 years old. So I'm not saying that I was, it was dumb luck, but it makes clear that I've had a fascination with Andean culture and technology for most of my 16 years of life. The Andes are a vertical landscape, and within this vertical landscape, the Inca culture in particular developed highly sophisticated engineering responses. So here we see 2 kilometers of straightened river at Pisac, where you can see the curving terraces on the left were the historical route of the river, and then by straightening it, building a canal, it reclaimed more land for agriculture. So we're talking about engineering at a grand scale in the Andes Mountains, and that's one of the things that we're here to both celebrate today, but also to try to understand and learn from. The road system, though, is perhaps the largest and most lasting and impressive work of Inca engineering, and so I'm delighted to be working together with the Smithsonian on a public exhibition on this topic. And when I was introduced to the Inca road system in 1995, I was very lucky to go and visit some stretches of the original road with Adriana van Hagen, who's a Peruvian journalist and archaeologist whose father wrote a book in 1955, Highway of the Sun. And so for me, you can imagine what a thrill it was to be along parts of the Inca road with Adriana van Hagen and Edward Francamonte, an anthropologist who really introduced me to Andean technology. And since that time, I've been actively working on the large-scale suspension bridges, which I believe are fundamental to the Inca road system. They make the road system possible. The Andes are divided up into regions with very difficult canyons to cross. Several months of the year, they're practically impassable because of the water. And Kenneth Wright, who spoke earlier, is braver than I am because he was willing to wade out into some of these rivers. And it really is a severe obstacle within the landscape. And yet, we know at least in the Inca Empire, large-scale suspension bridges stitched together the road system. And these were substantial works of engineering. One of the arguments that I make for that is the dark shapes on the left side of the cliff in this image are tunnels through the rock where Inca builders tunneled through the rock in order to reach the approach span in order to build the abutment for the bridge. And so this is not throwing a river from one tree to the other tree. This bridge was among the longest bridges in the world at the time. It was one of the longest continually used bridges ever built in the Americas. And the fact that the tunnel through the rock was constructed meant that I think it's appropriate to use the term engineering because it was a premeditated act of construction in order to place the abutment in the most favorable location. And these bridges survived up until the late 19th century. And so I used to think I was born a century too late because chroniclers throughout the ages documented these bridges, and really their technology wasn't surpassed for centuries. They were so appropriate to the Andean context and frankly the very long spans with the difficult rivers beneath. Looking down one of these bridges in the late 19th century, you can almost transport yourself back to the Inca period and envision how impressive these works are to us today and how impressive they must have been in the 15th century and in the height of the Inca Empire. Major bridges like this connected the main roads of the Inca road system leading to Cusco. And these bridges played a really important and strategic role, not only in the growth of the empire and control of it, but also in moving goods and data, as we're going to hear next from my distinguished colleague Gary Urton. They also give us insight into construction and maintenance of public works in this period, and they give us a sense of really cutting-edge technology in bridge construction, and I'm going to try to make that argument to you. So, on their strategic role, one of my favorite chapters in any book is this chapter from Book 3 of Garcilaso de la Vega, titled, "Many Tribes Are Reduced Voluntarily to Submission by the Fame of the Bridge." So if that doesn't convince you that these bridges were something special, and that the Inca was welcomed as a result of these because of the marvelous new work that seemed only possible for men come down from heaven. We could question how accurate Garcilaso is on some levels, but it's very clear from this that the bridges had an importance. And there's much more research that needs to be done on the dating of the Inca road system and therefore the dating of the bridges. But most of the major bridges seem to date to the Inca period. And I've estimated that at the height, there may have been as many as 200 suspension bridges throughout the Andean region that helped connect the road system. These were used to cross natural barriers, to also conquer new regions. You can see the growth of the Inca Empire. And during and after conquest, the bridges were strategically used. So if you read accounts during the contact period, the bridges are constantly being used in a very strategic way. One army will cross the bridge, then they'll cut it or burn it and keep going, and the other army will be delayed several weeks and aren't able to pursue them as a result. Both the Spanish and the Inca use this technique. And this gives us a sense of how insurmountable these barriers were without the bridges. The second thing about the organization, it's clear from the chronicles at least that the Inca himself is claimed to have played an active role in the planning and construction. So according to another chronicle by Betanzos, the Inca himself made a painting and a drawing of the bridges. And this is, for me, absolutely fascinating, the notion that the responsibility for public works went all the way down to the individual level of the Inca. And we also find provisions for constant repair and protection were carried out both as part of tax to the Inca and also as part of keeping the main tax to the Inca on the part of smaller communities and keeping the major roads in operation, with bridge keepers who we believe for the large bridges were stationed at the bridges in guardhouses. They repaired them continuously. They controlled who was allowed to cross, and we have some evidence that there were royal roads and royal bridges, and there were others that were used by commoners, and so there's more to be understood there. And one thing we've learned is that there were smaller bridges that were the responsibility of local communities. The other thing I want to emphasize is that this technology was not only among the longest spans at the time anywhere in the world, but they're also very durable and long-lasting. They were not surpassed until really the Industrial Revolution in terms of an ability to span such long distances. And in particular, the whole concept of spanning a long distance in tension was really the opposite of a European method of bridge construction, which was most common, building arch bridges in stone. Arch bridges are limited to a much shorter span because you have to build a wooden formwork first. It won't stand up until the last keystone of the arch is in place, then you can remove the wooden formwork. That doesn't work very well when you have deep canyons and very fast-flowing rivers, and therefore the Inca solutions were both appropriate for the terrain and also very unfamiliar to the Spanish when they arrived, who in their world a bridge looked like this, stone on stone in compression. We have evidence that some of the brave conquistadors crossed on their hands and knees. They called the bridges the work of the devil. And yet they also claim that the bridges were as solid as the streets of Sevilla. And we know that horses and cannons were able to cross these bridges. So these are substantial works of construction, but really fundamentally different worldview and in some ways emblematic of this clash of two worlds. Now, if you go throughout the Andean region today, you can find remains of Inca suspension bridges up and down the Sacred Valley, and there's ongoing research needed to document these remains because many of the bridges were in use up until even 100 years ago. You can find things like these two stone towers, the bridge crossing that Ken Wright taught me about and taught all of us about this morning may have had stone towers like this that could have been washed away over the centuries. And then abutments in the floor used horizontal stone beams to tie the cables off to, and multiple beams arranged in series. And what's very clever about this is that the masonry in the roadway serves as a level walking surface, but it also serves as a mass to resist the very large tension pull from the cables. So this is really an ingenious design, and these have not been well documented. In fact, you can see the stone in the top here, which is a stone lintel, but then it's carved and rounded and smoothed in order to receive the cable. So we need more documentation of these sites before they're lost. And we have from Guaman Poma the main elements of an Inca bridge. What you notice is the rope serves, a braided rope serves as the roadway. So travelers are walking along the rope that's suspended between two stone abutments. There are vertical ties linking these together. And so here we have all the elements from the 1500s of what an Inca bridge looked like. And almost incredibly, surviving today in a rather remote region of the Andes, one of these bridges has been there since the Inca period. This bridge near a community today of Huinchiri in Peru has been there for at least 500 years, and most remarkably, perhaps, the bridge is built entirely out of grass that you see growing on the hillsides. And you ask how you make a grass bridge survive for 500 years. I've had many students at MIT over the years come up with various answers. You build it out of, you dip it in carbon fiber solution with some kind of epoxy resin. But the short answer is that the grass is integrated within the communities on either side, and every single year in a 3-day festival, the bridge is rebuilt entirely. So not only do we have the bridge as an artifact from the Inca period, but we also have the process of construction. And on the first day, each household produces about 50 meters or 150 feet of cord to make ropes. The second day, the old bridge is cut, new ropes are installed, and on the third day, the bridge keeper installs the handrails and completes the bridge. So I'll just take you briefly through the festival. Collecting the grass, which is a type of ichu grass that grows and is commonly used throughout Peru. You can see a small cord about the size of your index finger emerging from the twisting. Those are laid out in bundles of 24 cords, and about 700 community members come together to build this. And over 2 days, those cords are twisted and then braided in a traditional rope walk. So you can see the ropes being passed as the braid is being done. And then the cable that emerges is about the thickness of your thigh, and that's the main structural element for the bridge, which is then passed across with a small traveler rope to the stone abutments. And even though they've been rebuilt and repaired over time, we believe they date, and the crossing dates from the Inca period. And here you see the main structure of the bridge with 4 cables for the floor, which are then tied off to a stone abutment. The scale is a little misleading. This abutment's quite large because those cables look small in this image, and are then tied off to these stone blocks embedded within the masonry walkway. At the end of day 2, in case you're tempted to cross, there's a banner put across that says it's not quite ready. And most of day 2 is spent pulling on the cables, taking slack out of the bridge, and so you can see that it's almost horizontal. It can't go quite all the way horizontal. And then on the last day, it comes down to the work of the ChakaCamayoc, or bridge keeper, who today is a man named Victoriano, whose family has been responsible for this phase of the construction for more than 300 years. So he's a direct descendant of a long, long tradition of master bridge builders, and his job is not easy over the rushing river, braiding these cables together. And while he's doing this, there are about 600 inebriated friends on the hillside who are yelling at him and calling for his demise. It's also a very important religious moment. The bridge, you can imagine, is extremely important for the communities, and many offerings are made to Pachamama throughout the construction of the bridge. And I became involved when a Nova television production filmed this, and this was the producer who was the first to cross that year. And he, like the Spanish, was rather terrified, and he said, I'm afraid if I lean out on the cables, maybe it'll just move out into space, and if I grab the other one, the bridge will flip over and dump me into the canyon. He said, does that ever happen? And one of the community members said, oh yeah, that happens all the time. Which of course is not the case, but and I'm absolutely thrilled. This is Victoriano, that a new documentary film, The Last Bridge Master, is documenting his family and their struggles to pass on this tradition in the face of a lot of other pressures in the period that we live in today. And I'm particularly excited about having him explain in his native Quechuan what this bridge means to him and his family and his communities. So this is really an incredible piece of Inca engineering that we are fortunate that has survived until the present day. As an undergraduate, I was lucky enough to tackle this project as a senior thesis, which involved a typical engineer's question: how strong were the ropes? So I did load testing on these ropes and found that a single main cable could support about 4,000 pounds in tension before failing. So that's about strong enough to lift up, 2 small cars. And then I said to my advisor, nobody's ever measured the bridge. I really need to go to Peru. And she was terrific and said, yes, you do. And I got to go to Peru and measure this bridge, and I found that the span is 99.5 feet, which we'll call 100 feet, and did an analysis that showed what, of course, the community knows, that the bridge has plenty of load capacity. This is about as many people as I've ever seen on it. And in fact, historically, there's a certain amount of engineering that's gone on to get the right number of cables for the needs. Then a few years later, with colleagues Lynn Hobbs, Heather Lechtman, and Dorothy Hostler at MIT, they taught a class on materials and Andean society, and we had students make cables using natural fibers. They braided them, and then we built a replica bridge on the MIT campus over this raging river. And we replicated the same way of getting the first traveler rope across and then pulling the cables across, stretching them between abutments. And the students really enjoyed this, you could imagine. We called the project ChakaCamayoc for the building next door. And our students are somewhat sleep deprived. And this was a really terrific exercise for all of us, and I got a lot of publicity at MIT for this. It was a great experience for the students and the faculty. And when the New York Times wrote an article about how the Inca leapt canyons, highlighting this bridge and our reconstruction, for 3 days on the New York Times website, this was the #1 most emailed article, which tells us that the public also has a fascination with these bridges and with the act of reconstructing this particular bridge. So this bridge has survived, even though a truss bridge from the 1960s was built adjacent to it. Work, play, religion, and technology aren't separate activities in the Andes. And that truss bridge, which was really imported, not integrated into the communities, is now corroding and falling into the canyon, where the original grass bridge for the last few decades hasn't been necessary to get across the river, but the festival must go on and the bridge is produced anyway. So we're very fortunate for that. So just in closing, thinking about what can bridges teach us, working on an exhibition here on the Inca road system, I would argue that there are lessons we can learn about their technology, about their social integration within the communities, and also about their environmental performance. The scale of the spans that they achieved not only evoked wonder at the time, but even more so today, the strength of fibers and tension. And one of our possible ideas for the exhibition is to mount a replica of this bridge here at the National Museum across the rotunda between 2 openings, which when we went and measured them recently, we learned that the span was 99.5 feet. And so we've been looking into the feasibility of that, have worked together on developing techniques to connect it to the existing building, and the concept is to have Victoriano produce a bridge, possibly as part of the Folklife Festival on the Mall in Washington, or possibly in Peru, and then ship it here to be installed. But we want to introduce the authentic bridge made by the community. And we really think that would draw people not only to this museum, but to the Smithsonian at large. We also want to work to document the festival, something that's really been lacking in the past, and these remarkable filmmakers who are working on this social sustainability side of the project and documenting the builders speaking in their native language about the process and technology of the construction. And we think that's tremendously important as well, not only to understand how this bridge has survived until today, but how it can survive for future generations, and to continue thinking about the way that the Andean worldview treats large-scale works of engineering like this, which I believe in some ways is fundamentally different from the way we think about large-scale works of engineering, and has things to teach us. The fact that the infrastructure is integrated within the community, and that everyone is involved in the upkeep in this way. And then also thinking about appropriate technology for the Andean context. And when we think about building for generations, this bridge is truly sustainable from an environmental standpoint. It's 100% biodegradable. It washes away in the river every year, and it regrows every year. The primary fuel for building it is the chicha, the corn beer, which is also grown sustainably. And so for me, you know, each of us has our own passions and our calling in life, but I feel very fortunate to have met Inca suspension bridges at an early age, and they continue to fascinate me. We have so many things that we still have to learn, and so I'll leave you with some longer term goals. Some of them we may be able to achieve by the exhibition in 2 years. One is a map documenting the major suspension bridges and even the minor suspension bridges, so we can begin to understand where they were, working from primary sources and trying to date and understand the roads as well, kind of like some of the work we saw this morning. And then surveying and documenting the abutment remains, which in the cultural landscape of the Andes Mountains, the abutments haven't ranked high on anybody's list. And yet, I think they're really important for us to understand the history of this technology and the history of the road system, and also shelters for bridge keepers. And I want to end by thanking Ed Francomont, who was known as Inca Ed, who was studying anthropology at Harvard and studying Andean society. And he realized if he really wanted to understand the Andes and learn how to weave and to think in an Inca way, that he needed to go and live there. And he lived for 20 years in Peru and spoke Quechua. And I'm very grateful that he introduced me to this topic, and there's still so many things that we have to learn. And I'm absolutely delighted that the Smithsonian and that the National Museum of the American Indian is helping to create new scholarship and to bring this important message to potentially millions of people around the world. Thank you.